Hello guys, welcome to Passlite Insight Academy. If you are writing physics exam and you have not prepared at all, come let me give you 50% of the exams and likely topic that you are going to see in the exam. So look at the board, see what you're having. Motion or projectile. There is no how you want to escape it. It's just come out every year. We have dimension, we have its energy, current, electricity, waves, and optics. Then you can also read on laser, you can read on semiconductors, machine, elasticity, and expansivity. So these are the likely topic that you should be expecting tomorrow in your exams. At least this is going to serve at least 75% of your exam. You don't need to be panicked if you have not read. So I will start explaining them one by one. Now, one of the topic is motion or projectile. You cannot escape it tomorrow. Look at the questions. A particle is projected horizontally at 15 meters per second. Solution. You can see it now. 15, that is initial. So U is 15 meters per second. From a height of 20 meters, the height is 20 meters. Calculate the horizontal distance covered. Horizontal distance is also known as range. That is your range covered by the particles just before hitting the ground. Then your G is 10 meters per second square. So this is it. And what are the formula that we used to use there? Please note this. Our motion formula is very important. If it's motion, V is equal to U plus AT. This is the first formula. The second is S is equal to UT plus half AT squared. Second one. And the third one is that V squared is equal to U squared plus 2AS. Please know this formula. And know when your U is 0. U can be 0 when they mention from rest or at rest. Then V can be equal to 0 when they mention to rest or to stop. So this is when your V can be equal to 0. Also, acceleration can also be equal to 0 when you have a maintained speed or at constant velocity or speed. So your acceleration is equal to 0. So let's go to projectile. But in projectile now, projectile formula, we have what we call time of flight. Time of flight is equal to 2U sine theta over G. We also have what they call the maximum height, which is U squared sine squared theta over 2G. We also have what they call range. Range is equals to U squared sine 2 theta over G. So which one are you going to use there? Anytime you are not given theta, that means don't use this. Just say 2U over G, U squared over 2G, U squared over G, when the theta is not given. Also, we also have a formula for R is equals to U cos theta, relationship between time and range. So if you are not given this theta, you can also use R is equals to U times. So what is formula for this T? T is square root of 2H over G. So you can use that. So join these two together. Let's do that here. We are looking for the range. Range is equals to U times, what is your T? Square root of 2H over G. So R is equals to, what is your U on the board? Your U is 15 times square root of 2 times, what is your height? Height is 20. What is your G? Your G is 10. So R is equals to 15 times 2 times this, that is 40. 40 over 10, that is 4. So R is equals to 15 times 2. So that is 30. The unit of horizontal distance is meter. So that is 30 meter. Thanks. So this one is on its energy. A nursing mother prepared her baby's milk mixtures at 85 degrees Celsius. You are going to write that 85 degrees Celsius in a feeding bottle. In order to cool it to 40 degrees Celsius, the arrow moved to 40 degrees Celsius. She immersed the bottle in an aluminum bowl of its capacity 90 joule per Kelvin. So the its capacity AC 90 joule per Kelvin, containing 500 grams of water. The mass of water is 500 grams. Take it to kilogram divided by 1000 is 0.5 kilogram. At 26 degrees Celsius, so liberated to 26 degrees Celsius. 26 degrees Celsius. So this is the three temperature that we are having. From here to here, it cool down. And then from 40 to 26. So like, what are you going to have here? This one is mixture. Why this? Because from the question, this is mixture. Why this 26 will start for the aluminium? So we have the one of aluminium and we have the one of water. So this place is aluminium and water. So as you can see that now. So let's continue. If the mass of the mixture is 300, now the mass of the mixture now, 300 grams. 300 grams divided by 1000, 0.3 kilogram. Calculate the specific capacity of the mixture. So I don't know, the C of the mixture is unknown. Let its losses and its capacity of the bottle. Specific capacity of water is 4200 joule per kilogram per Kelvin. So the specific capacity of water now 4200 joule per kilogram per Kelvin. So this is what we are having now. So from our formula, I told you that this one is losing from 85 degrees Celsius going down. Why this is gaining? You can see from the arrow now, this is 5 to 40 to 26, losing. Why this one they are gaining backward there? So from here now, you can actually look at its gain first. What is your its gain? There are two its gains here. With this is gaining, this one is losing. So your aluminum is gaining and your water too is gaining. Q is equals to MC theta. For your water, the mass of water, specific capacity of water, and the temperature of water. All this is water. Let's go. What is mass of water? Look at the ball, 0.5. The specific capacity of water, check water, 4,200. Times the temperature now. The difference between here and here, 40 minus 26, that is 14. Because here is 85 minus 40, and here is 40 minus 26. So that is difference in temperature. So you can multiply these together. So when you multiply this, you have 29,400 joule. So this is its gain of water. So let's look for the one of aluminum now. You are given its capacity, and formula for its capacity is Q over theta. Change the theta. So if you cross multiply this time, Q times 1 is Q. H times, so we are having H dot C times theta. So that is the formula. So let's get what is its capacity of aluminum? 90. Then what is the temperature? Temperature is the same, 14. So 90 times 14 to 60 joule. Then let's add all the heat gain together. The heat gain, the total of the heat gain now. The total heat gain total is equals to, so add them together, 29,400 plus add this 1260. So what is your answer? 3660 joule. So this is your answer of your heat gain. So let's go to the heat loss of the mixture. So your heat loss of the mixture now, its loss by the mixture, which is Q is equals to MC theta. Q is equals to MC change theta as well as write it. So what is your M? The mass of the mixture now. Please, that is why you have them. This water mixture is 0.3. 0.3 times the specific capacity of the mixture. M we don't know. But with the temperature now, the temperature of the mixture is 5 minus 40. That is 45. So multiply this times this. What do you have? You have 13.5 S. So then we are going to, from the question, even though they mentioned neglect its losses and its capacity of the bottle, meaning that its gain is equals to its loss. Under the principle of a mixture, its gain is equals to its loss. So what is your its gain on the board? The total answer of your its gain, 3060, is equals, what is your its loss? 13.5 S. So divide both sides by 13.5. Divide both sides by 13.5. This cancel this, S is equals to, so this divided by this, you are having 2271.11. That is joule, the units, joule per kilogram per Kelvin. So this is the specific capacity of the mixture. So the same way you can be given questions on electrical component, the same way. So electrical component formula, so in case if you see question like on electrical, the same way that we solve this, so it's also the same way you are going to solve that one too as well. Your Q is IVT. So this is your electrical formula. So use your IVT against any of this formula that we use here, MC change in theta. So this one is always its loss. For anything electrical is its loss. So please you can also use this. And at the same time, under latent heat, you can also use this formula to Q is equals to ML. So this is an additional formula you can use on its capacity, apart from the one we use today. So if you have, depending on the questions, if the question give you latent heat, either latent heat of fusions or latent heat of vaporizations. So use Q is equals to ML. But here, if you are also given questions on electrical, they will give you the current, the potential difference, and time. So you can use that. Or in case they give you the power and time, you can also use that. There's a formula that says PT, called power is IV. You can also use PT. So these are the formula that we use on its energy, specific capacity, its capacity, and latent heat. And please don't forget to like, share, and subscribe to my YouTube channel so that if I post any questions, you'll be able to notify it. I will send a lot of questions on physics, mathematics, and chemistry. Please follow for the updates. Thanks.